Interesting enough, this is one most students struggle with, even though it is our most basic one. So we want to identify our vertex. So our vertex on this one is at 0, 0 because there is nothing being added or subtracted to our equation. And so it's just at 0, 0. Our HK is 0, 0. So there's my vertex. My axis is x equals 0 because it's always x equals the x coordinate of our vertex, or x equals h. Hey, then we have direction of opening. So this is concave up. So concave up. So since it is concave up, we then know that it is a minimum. And some of you struggle a little bit with whether it's a min or max, so then it's easier to graph it first. Although we haven't talked about the actual width of it yet, you can still just do a sketch to give yourself an idea if it's our min or max. So this is a minimum at y equals 0 because it is our y coordinate of our vertex. Okay, and then for this, I said you don't have to worry about our intercepts yet. We'll worry about that next week. Our stretch on this one is normal because our a value is 1. Our domain on all parabolas that we're doing here is negative infinity to positive infinity. And then our range, in this case, if you do interval notation, it's from 0 to positive infinity. You could also write it in inequality, which is y greater than or equal to 0 because the parabola goes up. So this one, our HK, a lot of students want to put -1 for the h. Remember, h is what's inside the parentheses. So our h on this one is actually 0. So our vertex is going to be 0, -1, which means our axis is x equals 0. And then our concave up or down on this one, we are concave down because our a value, the -1/2 there, that's negative, so that is concave down. Which means if we're concave down, we then have a max at y equals -1. And then our stretch. On this one, our stretch is wide or compressed because the a value is 1/2. So if it's between 0 and 1, it's wide or compressed. If it's greater than 1, it is stretched or more narrow. Our domain, negative infinity to positive infinity. Range, this case, since it's going down, it's going to be negative infinity to -1. Oh, I did those backwards. Or y is less than or equal to -1. So let me graph this one. I'll talk about range. So we're 0, -1. And we're wide. So make it look a little more wider. Now, to do range and interval notation, you always start at your lowest value and work up. So I start down here. Well, the lowest value we hit since our parabola is going down is negative infinity. And we work all the way up to -1. That's where it stops. When we look at number 1, The reason it starts with 0, because as I start down here in negative infinity, work my way up, there is no graph yet. And then I hit 0, and then I go from 0 to positive infinity. So that's why that works the way it does. All right, number 3. Okay, so our vertex is -1, 4. Our axis is x equals -1. We are concave down on this one. Which means we have a maximum at y equals 4. Our stretch on this one is normal. Our domain, negative infinity to positive infinity. And then our range goes from negative infinity to 4. Or you can say y is less than or equal to 4. All right, number 4. So our vertex is at 2, -4. Our axis is at x equals 2. We are concave up, which means we have a minimum at y equals -4. Our stretch is wide. Domain is negative infinity to positive infinity. And then our range is going to go from -4 to positive infinity, or y is greater than or equal to -4. And then plot this one. Something like that. Hey, number 3, I forgot to plot for you. So -1, 4. And goes down. Now on 5 and 6, these are in standard form. So if we want to do these, we have to remember that x equals -b over 2a. So as we look at number 5, I get negative, and then my b is a -6. So a lot of students get that wrong because they put just the -6 there. They don't put the negative from the formula as well. And then all over 2a, a in this case is 1. 2 negatives make a positive, so we get 6 over 2, which is just 3. So then that becomes my axis. It also is the x-coordinate of your vertex. Once you have your x-coordinate, you can get your y-coordinate by substituting that value in. So then y equals 3 squared minus 6 times 3 plus 5. 3 squared is 9. Negative 6 times 3 is a negative 18. And then plus 5. 9 minus 18 is a negative 18. Plus 5 is negative 4. So my y value for my vertex is negative 4. Okay, and then for concavity, it's still the same. You look at your a value. Our a value was 1. And so we'd be concave equals